I'll wait for people to join.
Is there more than one presentation in this session, or is it just me?
Yep, Alex will go first, and then
Okay,
I'll announce both of you.
awesome. Okay, I'll go on mute then until it's my turn. Now, do you recommend turning on video?
That is your personal choice.
Okay.
You can feel free to do whichever you choose.
Awesome.
Yeah, I think I'm going to do video for like the intro, but then I'm going to turn it off because I think some people yesterday were having trouble with it soaking up a lot of bandwidth when they were trying to stream that and do the screen share and everything else.
Perfect. Good idea.
All right, so the first presentation is going to be Mobile GIS Data Collection Alternatives, Fulcrum Map in the US and Beyond by Alex Smith.
All right, thanks, Annika, for the intro. Can you see my screen all right here?
Yep, Looks good.
All right, great. And it's saying I can't actually start sharing my video, but that's okay because I was just going to have it on for a minute. But yeah, so good morning, everyone. Thanks for coming to this session on mobile GIS data collection alternatives using the Fulcrum app. I'm Alex Smith, and I'm the GIS technical lead with EHS Support. I've been doing GIS for about 13 years. I think I started with 9.2 when I was in college in 2007 and 8. And I've been in consulting for about 8 years now doing GIS. And like a lot of you, we're always looking for new ways and efficient ways to perform field data collection. So I hope this presentation is going to be helpful if you're looking to move either from paper forms into a digital format, or if you'd like an alternative to the digital form system that you're currently using. So we're going to start with an overview, some of the problems that we faced a few years ago before implementing this program. And we'll follow with kind of a general overview of the advantages of digital field forms over paper. We're then going to kind of go into the Fulcrum mobile app itself, which is the solution we decided on, and break down some of the advantages and limitations there. And after that, illustrate some of these advantages with 2 actual projects where using Fulcrum has saved time and money for our clients. And we're going to finish up with some of the final products and how we can create efficiencies after the field event has concluded. And as a disclaimer, before I keep going, I didn't make Fulcrum. My company didn't make Fulcrum. It's just a third-party application that fit really, really well with what we were trying to do. And I just kind of wanted to share it here. So before we could really decide on a platform, we had to kind of outline the capabilities we were looking for. EHS Support collects a huge volume of field data, and most of it was being collected in those little yellow field books or on paper forms. This led to a host of issues when we went to load this data into our EHS database after the sampling was concluded. Handwriting could be really hard to read, and everything had to be manually transcribed, which really increased the chance for errors. So an S that gets recorded as a 5 could have really severe issues down the road once the data was used. So we wanted a way for the data to come from the field, like in a tabular format, and one that we could leverage without having to decipher anyone's kind of chicken scratch handwriting. We also wanted something that was location aware with mobile mapping capability. So like looking at that sketch on the right, that's an actual field map I got, and that's not something that's really easy to geo-reference or even read for the most part. And how much better would it be if they had actual GPS data from where the samples and observations were taken? And how great would it be for them, in the field, if they could see their position relative to some of these features and things like property lines or buried utilities. So what are the advantages of digital field forms over paper before we get into the advantages of this specific platform and why we chose it? The first advantage is flexibility. Digital field forms are customizable for each project and can be replicated for different projects really quickly. So if a form doesn't work, we can really change it to anything. Many digital field forms can also track changes of attributes and locations, so you know who modified each field and when, and in some cases even where they were standing when they did that. So with digital field forms, you can also preload data and make changes from the office even when the teams are in the field. So we're actually able to add new fields or locations to a form, like while the sampling team is actually out there, without forcing them to stop or losing data. It just shows up the next time that they sync. So this allows us to keep up with changes in scope without having to recreate and send a bunch of PDF maps, which we used to have to do, and people would have to zoom in on their phone and try to see where things had moved to. And it can also use GPS. And this actually includes a couple different Bluetooth GPS boosters that can really increase the accuracy of the mobile GPS instead of relying on paper maps to mark locations. The GPS also allows you to see your location on site for most apps. Having the information digitally allows for really quick exports to Excel or PDF, Word forms, or other programs like Strader, which is something that we use for boring logs and things like that. So our field teams really like being able to receive exports by the time they get back to their hotel after a day on the site. And having the data synced to the cloud allows us to do that. It also gives you a distributed and redundant work environment. So if you drop your paper field forms into a ravine in the middle of your sampling event, you're going to have a pretty bad day. But if you drop the iPad or run over it with a truck, which actually has happened before, you can just pull out your phone and keep going on that. And with waterproof cases, we've actually found that iPads work a lot better than paper field forms in nasty weather because there's nothing to get soggy and smear. I know we have those little like write in the rain notebooks, but carrying paper forms around on a clipboard is usually just asking for a headache when you're in inclement weather. It also means we don't have to digitize handwritten field notes. So remember, is that a 5 or an S? Further, it allows us to capture more revenue in-house in the case of subcontractors. So we're not having to pay subcontractors for them to transcribe anything and create tables. It also looks good to clients and regulators to have a structured digital field form. So if a client walks onto a site and we're doing all of our work on iPads, what are they going to think? They're going to think you guys are pretty high tech. So you can kind of flip through and show them like, these are the wells we're sampling. This is where we are on site. This is what we're collecting for. And you can also give them a login so they can monitor progress from the office in the desktop interface. So the platform that we decided on that does all that for us is called Fulcrum. It had all the advantages over paper forms that we just discussed, and a few more we're going to get into in a bit. So Fulcrum is a mobile application that's paired with a desktop interface that can be used seamlessly to collect and transmit data across multiple platforms. So those of you that are familiar with Survey 123 are going to see a lot of similarities here. And it works with any Android or iOS device. In our case, these are either personal phones or company-owned iPads, really most different smart devices. Fulcrum also gives you that distributed work environment where many devices are tied to the same form, and the cloud syncing means that data can be accessed from more than one device at the same time. So Fulcrum's used to create fillable field forms tied to a digital site map that uses device GPS. So Fulcrum's the program that the forms are created in, but all of the forms are custom made by EHS staff. So think of Fulcrum as like the frame of a car, and we decide if it turns into like a race car or a monster truck or something else. And there are a few pre-made applications that the company that makes the Fulcrum app have put out, but most of ours were created in-house because we have a lot of really specialized sampling events. So we're going to go over some actual project examples in a bit, but think about a digital copy of a storm damage assessment form or a lead-based paint sampling form. So we can add data to existing locations like sampling monitoring wells, and that's the example that's up on the screen there, or collect new locations like soil borings or photo reconnaissance records. It can even replace forms that are not really sample related, like we use it for all of our daily tailgate safety meetings and equipment calibration sheets now too. And as with us being an Esri shop, Fulcrum also supports full integration with ArcGIS Online. And finally, Fulcrum has a backend with a really cool query utility, an API that allows the data to be accessed with SQL queries. In this case, it's PostgreSQL, which was something our team was already pretty familiar with. So we're going to discuss both the Arc Online integration and SQL later on when we get to the export section. So I know what you're thinking. You know, I can do all of that with Survey 123 or Cunipy or Equus Collect or another program. And I mean, for the most part, you're right. Most of those features are common for the major digital field form options we kind of reviewed initially. So why did we pick Fulcrum specifically? And the first one that really interested us was the cost and the billing structure. And this really continues to be one of the biggest drivers. $40 a month per account. And we have the Cadillac plan, so there are others that are definitely cheaper. But the important thing is that this is actually billed monthly. It's not a monthly cost that has to be paid yearly or prorated for a partial year like most other software. So this generally means that for a given sampling event, when we have 2 people out there for a week, we're only getting billed $80 instead of having to pay for an account for the whole year for each field staff member. When we were first looking, I think Fulcrum was around half that price, but we've stuck with it because it's still like vastly less than we would pay for any of the others we evaluated. For example, I think an Esri field worker account's like $350 for a year now. So if we use the Fulcrum account for a whole year, the Esri option would definitely be cheaper, but that really doesn't happen all that often with the kind of work that we do. Most of our sites are sampled quarterly, so think like 1 or 2 weeks every 3 months. So being billed monthly, this ends up being about half the cost of paying for an Esri account for a year. So some months we might have 20 accounts, some months we only have 4 or 5. You know, in December, there's not a lot of sampling that happens, so it gets slower. So this ensures that on those off months, we're not being billed for all 20 accounts. Equus Collect was another one we looked at. It's made by Earthsoft, and that was even more than Esri. And although we use Equus as our in-house database, which is another Earthsoft product, the cost and the interface were just not great. And we looked at another field form option called Cunipy that I think was $100 a month. That included a bunch of pre-made forms and was set up remotely by the company that makes it. So this was sort of like an outsourced option. And that meant that revenue that we normally capture in-house would have to be essentially subbed out. So we kind of decided against that one. And that was another one where the billing was over the course of a whole year. Another advantage was the flexibility or customization of reporting. I've already mentioned that Fulcrum has this SQL backend that allows you to interrogate the data and make custom exports. And this isn't really something we saw anywhere other than with some of the Esri products. Most of the others were just some sort of graphic user interface, which Fulcrum also has in the form of a report builder function. Fulcrum can also be set to send email reports automatically based on whenever new data is collected or triggers, or also send like text notifications too. Finally, integration with Esri file types and ArcGIS Online is a feature that while that's available obviously in all of the Esri field sampling products, it isn't really as common with a lot of the other digital field form apps. So we can add any layer that can be made into a shape file to the mobile map. This could be things like property lines or areas of concern, buried utilities, wetlands, things like that. We're also able to display live Fulcrum data in Arc Online products. That's a relatively new product offering, but it works pretty well in our experience. So if we have a set of like 100 soil samples that are being taken across the site, we can actually set up a web app or a dashboard in Arc Online that'll allow the project team to monitor the status of the project from the office. We also had one project recently where access to this type of web app was given directly to the client so that they could monitor our field team's progress directly. So then what are the limitations of Fulcrum or any digital field form versus paper forms in our experience? And most of these are going to be really familiar to any of you that have ever set up a digital field form program and encountered some resistance, we'll say. The first is that typing speed, especially for, we'll say, seasoned field staff, can be a limiting factor, and that like really granular data might not flow as well with standardized forms as just kind of writing it out as a sentence. So for example, with like really complex lithology, text fields might take longer than writing things out with a pen. And this can be mitigated by having a really good schema and allowing for other and comment fields with detailed instructions. And even if some things do take longer, we still really make up a bunch of time on the export when no one has to transcribe those field notes. And the structure of the form ensures that field staff members don't miss a required piece of information, because then it just won't let them submit the record. The second one is there was some worry that pick lists and default values take some of the thinking out of data collection. So by having too many pre-filled fields or otherwise encouraging complacency, we'll say. So for example, again, with that lithology, if you're pulling up a brownish gray sand, but your only options are brown or gray for color, there might be a tendency to just kind of pick one and go about your day. And this is again where the option of an other description is important, as well as like really good training of field staff. Forms are also set up in such a way that the field team still has to engage with the data. So I know when sampling groundwater, certain parameters like temperature and turbidity, and there's several others, have to be stable for a certain period of time before you can sample. Some other applications have like a little light that goes green whenever all of those line up. We decided to opt to not have that. So we have like calculation fields that do the math for them, but they still have to kind of interact directly with the data. And the third one, and maybe this should be the first because this is one of the first ones that always comes up, is the worry of technological failure. So far, we've had no unfixable software issues over the life of the program that couldn't be attributed to user error. But technology can definitely be fragile at times. We had one instance, I think I mentioned earlier, where someone left an iPad on a truck tailgate, which fell off when the truck started moving and was subsequently run over and just crushed. But even with that single iPad that we lost so far, the data was preserved because it was synced to the cloud. Another is that you need a data connection to sync to the cloud. We do work on some really remote sites in some cases, but you can work offline and then just sync data when you get back to an area with signal. It just means you have to be really careful with the equipment if you have unsynced records. And paper really has the same limitations if your notes get dropped into a river or something like that. So now let's look at a few cases in the field where we've been able to really greatly increase efficiency and accuracy using this application. The first is a lead-based paint survey that EHS conducted in New Zealand. So the New Zealand Defense Force maintains on-base housing for service members, just like the US military does. And most of this housing was constructed before 1970, and the use of lead-based paint was really, really common. So EHS was tasked with a large-scale sampling of several hundred houses. Several different types of samples would be taken at each location, then sent to the lab for analysis. So there'd be like paint chip samples and water samples and soil samples. I think there were about 6 or 8 different types. So the initial plan was to use Fulcrum to collect field data and load that field data into our EHS database along with the lab analytical data. Later on in the process, the client decided that they would rather use their own internal analytical database, which was a very different format from our own. So we now had to kind of figure out a way to convert the data to their specific format without losing efficiency. Ideally, this would be done with no manual entry or manipulation of data from the office. So the goal was to have EDD, which is electronic data deliverable, created in as automated a way as possible to really cut down on the chance for human error. But before we could do that, we had to develop a field form that was usable in the field for the field teams, but would also allow us to extract the needed tabular data when the analytical data was received from the labs. Luckily for us, New Zealand uses the same lead-based paint sampling forms of the US Department of Housing and Urban Development, and I have an example of one of several of those on the right. Wanting to keep it as simple as possible for the field crews, we actually combined all of the various HUD forms into one Fulcrum mobile form so that all the data could be collected without having to switch to a new form every time a new sample was taken, as you would have to do with the paper forms, because there's like one for soil sample, one for water sample, one for paint chips, etc. We made use of a really strict schema so that the data coming out after the sampling event would be useful from a database perspective and consistent across the 5 different sampling teams that were going to be out there. So for example, one of the fields in the HUD form is size of sample centimeter by centimeter. So if we just left that as a text field, we could have any number of entries like 5 by 10 centimeters or just 5 by 10 or 5 space 10. And more importantly, there'd be no easy and consistent way to programmatically find the area of each sample, which was required for the output. So instead of that, we just used 2 separate numeric fields to capture the data, and then we could use that to calculate the sample size, or if we needed to concatenate it into something that looked more stylized, like 5 by 10 centimeters, we could do that while still being faster for the field team to enter than writing out that whole 5 by 10. So as we repeated this process for kind of every similar field. And as with all Fulcrum forms, all location and records were location aware, and they were mappable during and after the sampling event. So every parent record, in this case, the house was assigned location data, but also every child record, in this case, like the individual samples, were assigned location data. We also had to convert to New Zealand UTM, which is the only thing that their database would support, and Fulcrum runs on WGS 84. And we were actually able to do that live in an app with something called a data event, which is like a miniature script that runs in the form. Also, we wrote another script that would lock records for editing after 10 days so that field teams couldn't inadvertently edit older records. So now we had a mobile field form with all the required information for the survey. The next step was to turn that data into something usable from a database standpoint. As I mentioned a few times already, Fulcrum has a tool available called the SQL Query utility. And again, this uses PostgreSQL to query and manipulate data. So the client had an ESDAT database, which uses a 3-file format for loading data. And these files are location, sample, and chemistry. So location contains information about each house. Sample contains information about, obviously, each sample. So that would include like the date, sample time, and other parameters. And chemistry would include the lab results for lead testing. So location and sample would largely be populated with data from the field, while that chemistry table had to be populated with both field data and lab analytical data. So we could use the query utility to extract the needed data from the field forms, but we had to figure out how we were going to join that with the lab data that came in Excel sheets, and it was really a different Excel sheet for every house. So the solution we came up with was to create a separate form that wasn't visible in the field to kind of serve as a data warehouse. We could then use the query utility to join two forms together using unique IDs and generate the needed EDD files. So this is a lot like joining on a common field in ArcGIS. It's like the same principle. Once complete, the only thing we really needed to do was create and update EDDs, was to run 3 queries and copy the results into an Excel file. So there was no hand entering or transposing of data at all. And the result was a really efficient and accurate field data collection system, and really required minimal time in the office once it was set up. Unfortunately, COVID put this project on hold when it was about halfway complete, but we're definitely looking forward to continuing the project after the lockdowns are lifted over there. So that last example was a pretty complicated project that used a lot of different bells and whistles to link everything together. The next examples I'm going to highlight is a little more straightforward, but still very complex use case for Fulcrum. So EHS Support in this case was tasked with inspection, sampling, and continued upkeep of this groundwater treatment system for a decommissioned refinery adjacent to a residential area in Heath, Ohio. So for those of you that don't know, groundwater treatment systems pump groundwater from underground to the surface. They remove various contaminants and then inject the clean water back into the ground. And that cleans the subsurface water over time. The system was very large and had been constructed by several different consultants over several decades. And each consultant had used paper forms to record inspection data. And as new consultants took over, the forms were modified. Paperwork became a snarled mess of forms. So some forms had to be filled out daily, some were weekly, some were monthly, and some even had a daily and a weekly session on the same form, which made filing records a real nightmare. Also, anytime a new employee would perform field work on the site, they would need a rundown on the forms. So we wanted to digitize these forms to make life easier for the field staff, but also make the data more usable to the client and the data geeks like us in the office. So after creating test forms based on a lot of the existing paper forms, we went through kind of a long iterative process with the senior field staff to improve them as they spent time using them in the field and deficiencies were discovered. So we were able to add descriptors as far as how often each form should be used and which building and gauge various readings were taken from, or any actions that had to be performed before sampling. So having a tooltip note that says, turn the big yellow valve all the way to the left before sampling is a lot easier for a new field member to understand than ensure air sparge system on standby. What resulted was kind of a step-by-step process for how to complete each form that new employees could follow within the form itself. Time saving so far has been about 1 hour per person per day. So at standard billing rate, that'd be about $2,400 per employee per month. And now they only have to carry an iPad instead of several clipboards and folders. And another plus is that you can actually read the data now. We know the handwritten stuff can be hard to read, and all that data is in one place, not different notebooks or filing cabinets. And it's also accessible by every other team member that's out there almost instantaneously after it's synced. And finally, we can now import that data into Equus with a series of queries without having to transpose anything or any handwriting into Excel. So far we've digitized 22 different forms that used to be paper for this site, and the filing cabinets have stopped multiplying, while definitely saving the client some money in the process. So apart from those 2 sites, there are several other benefits of having an iPad or other device on site. We use them for health and safety green cards. So these are kind of recognition of positive or negative safety conditions and near misses. You can also have other things on an iPad than just Fulcrum, like OneNote or SharePoint or historic aerials, historic photos of locations, or like utility clearance photos. And also just having that weather forecast information is helpful too. You can have digital instead of paper field calibration logs, which we've started using. You can also create photo logs that cut the creation time of the finished log to kind of a fraction of what it used to be with just a camera and a field book. I've also been using Fulcrum for all of our daily tailgate meeting documentation while people are out there. So these are some of the exports we've been able to create that aren't strictly spatial data, but have saved a lot of time. I've already mentioned that we were able to create the ESDAT EDD for the New Zealand Defense Project and the EQUIS EDDs for the Heath Project, but we've been able to set those up for other databases as well. Also using the SQL interface, we've been able to create import tables for programs like Strader that are used to make boring logs. So these programs usually have a multi-table import. One table might have like drilling and coordinate information, while another one has PID readings and another one has lithology information. And with SQL, we're able to extract and format all of those tables from a single form that the field teams are using in the field. So they don't need to be switching back and forth between different sheets to record that data. We also created several neat batch printed Microsoft Word files. So some clients and regulators have these standardized forms that we have to populate. You know, we found that even after using Fulcrum project teams, we're still having admin staff kind of manually copying stuff into these standard forms. And the neat part about being able to export directly to Excel is you can take advantage of Word's mail merge function. So just like you do with form letters, you can map data fields to specific lines in a form, and what used to take, you know, hours of manually entering data can now be done in significantly less time and with a lot less potential for human error. So my goal with this project was to give you an idea of what alternatives might be out there to what you're using, or if you aren't using anything right now, to show you the efficiencies that digital field forms can introduce into your workflows. So this concludes this section of the presentation. I'd definitely be happy to answer any questions that anyone has about some of the things we've been able to set up. But before I do, I've included a username and a password if you want to take a screenshot or write it down. I've set up a training account with a bunch of different live applications on it. So if you want to download the Fulcrum app yourself and check them out, there's no cost to you for this. This is like our internal training account. So you're free to log in and play around with some of those forms that we've been using in the field. You know, if this were in person, I would have had a bunch of iPads or something up front that people could use. But I thought this was a good solution to still give people a little bit of exposure. So I guess with that, I'd be happy to answer any questions that anyone has. See, I know there's two chat things up here. Yeah, it looks like I don't see any questions yet. How am I doing on time? Do I still have a couple minutes? Or have I been muted the whole time? No, looks like I'm not. All right, well, from my counter, it looks like there's still 2 minutes left in my half hour. So what I might do is just switch out of that and just do kind of a demo of how the forms are actually constructed and how easy it is to create an application. So we've got, let's just look at this one as an example. Oops. Put a better one up here. All right. So this is a lithology form that we made, and it's a pretty long one, but all of the fields, it's really nice. They're just drag and drop. So if you wanted to add a new text field, you could just add it in wherever you need it. I think this is pretty similar to Survey 123's interface from the last time I used it. And I'll delete that so that that doesn't confuse anybody. But the cool thing about a lot of these fields is they can be set to be conditional. So as you're going down through the different fields, if you pick like a granular soil type like sand, it'll give you all of the fields you need to fill out for a sand, where if you pick something that's like a clay, it's like a more cohesive soil, it'll just give you the fields you need to fill out for that. So if I preview the app here, So this is kind of what it would look like on an iPad, other than you would be using your finger instead of a mouse, but this will have the same real function. So if we were at, let's say, we'll call it SB01 is the place we are sampling at. And I'm going to add a lithology record. So let's say we start at 1 foot and we go to 2, and then it's native soil. We can pick our colors, if there are models, and then once we pick the major lithology, that's when the field starts showing up. So if I pick clay, we've got something different than if I pick sand. And we've got all of our USCS codes loaded in here. And then we can pick our minor lithologies are in here. And again, that kind of controls what other fields show up. So here we've got like grain size shows up because we picked sand, and then just some descriptive instructions for other things to include in the notes if they're applicable. So the one other thing that's kind of cool about this is, go back, we actually have a sample counter down here that runs on a query that hits the cloud server. So every time someone adds a new sample and syncs it, then this counter updates on every record. And then what we had to do on this site, I think, was we had to take 1 QC sample for every 20 regular samples. So then this is just a calculation field that divides the total number of samples in the sync to the database right now by that 20. So you know how many QC samples should have been taken. Also have a couple fields that auto-populate based on some rules. So if I go in here and add a sample, let's say it's at the 6 to 8 foot depth interval, we have an auto-populate field that will fill in what that sample ID is supposed to be. And I can add our date and time if I want. Say that looks good. And we're going to say there aren't any dupes collected, but if there are, then it'll give you the sample IDs that those dupes are supposed to have. But overall, it's really easy to learn, if you just have a basic understanding of kind of how databases work, or even just how to work with attributes in ArcGIS. It's kind of like you're creating a blank feature class almost, or a blank shape file. So we've had a lot of success with this. So I will stop sharing my screen. And I guess if there are any questions afterwards, feel free to send me an email or try to catch me at one of the other sessions. So thanks, everybody.
Thank you, Alex. Our next presentation is going to be Utility Network Meets Cloud Services, Modernizing Infrastructure Management by Steve.
All right, you guys should be able to see my screen here, and I know that this is being recorded, so please feel free to reach out after the fact if you have any questions or comments. But my name is Steve Mulberry. I am a geospatial innovation strategist here at GIS Inc. And if you weren't aware, we got acquired earlier this year. So GIS Inc. is now a continental mapping company. This is very exciting news for us and our customers. And today I want to take a few minutes and share some strategies and thoughts and lessons that we've learned from helping our customers adopt the utility network and how to leverage cloud services. And both of these technologies we understand can be challenging, when to use, how to make the migration, what are the best practices for making the switch, when to make that switch. But we truly believe that all organizations can benefit greatly from these two technologies. The utility network and cloud services truly introduces this sort of modernized infrastructure management platform. And I'm going to leave that QR code up there just for a couple slides in case you want to grab my contact information, but please feel free to contact me after this presentation. So let's kind of talk about the key takeaways that I hope you get out of this presentation. And that is first, to understand what you need to know about both the utility network and cloud services. Now, obviously, you don't need to implement both of these at the same time, but we do find a sort of a synergy that you can have and leverage when migrating both the utility network and cloud services, if the cloud is in your discussions for leveraging that technology. Second, we want to talk about the benefits that you receive from both those technologies. And then finally, what you need to do and what are some of the things you can do to get started understanding the processes and flows for migrating to these platforms. So let's start off with talking about what you need to know. And I want to first focus on some cloud adoption understanding. Now, when I started at GIS Inc. back in 2009, I helped deploy our first cloud solution using Amazon Web Services. And since then, you can see from this chart the trend that we've experienced with organizations adopting the cloud. Obviously, with the COVID pandemic over the last year and a half or so, more folks and more discussions about adopting the cloud have definitely surfaced to the top because of the remote workforce, being able to implement web GIS more openly throughout the organization. But we also see this as a trend in the industry, right? The industry is telling us the same thing. This chart from RightScale shows the cloud adoption rate that you can see the big three there, again, Amazon, Microsoft, and Google. And what I take away from this is first, the adoption rate obviously is increasing, but these cloud providers are competing for our business. And competition is good, right? It drives the cloud services costs down. And so now I think more than ever, it's a perfect time to look at cloud services if you haven't already done so, and start to find a way or see how this can be implemented within your organization to leverage these cloud services. It was interesting. I just saw an article just this past week where Microsoft is really being aggressive in its costing charges for cloud services, which is going to be good for all of us because it's going to help drive the other competition down there. Also out of this report, though, that I read, I noticed that they did a polling for challenges that companies have when implementing the cloud, both enterprise and small to medium businesses. And what's interesting here is some of the things that we'll address in this presentation, but managing cloud spending, right? Understanding how to really get the full benefit of the cloud without breaking the budget, right? Breaking the piggy bank there. Governance, security, compliance, all those things are very important when talking about creating the right secure infrastructure for deploying ArcGIS in the cloud and providing users access to the information. But you can see some of the challenges there, and we've been doing this for quite a while, and we understand how to overcome these challenges and can help mitigate some of the risks that are associated with this. And with any technology adopting, so the utility network and cloud services we kind of think fall into this sort of cloud transformation or technology transformation. And this may not be the perfect analogy here, but we're going to use the flip phone to the smartphone comparison here. So if you remember back to the flip phone ages where you had this really nice number pad that we got used to, but the smartphone opened up this touchscreen, and to kind of confess here a little bit, when that first came out, I thought to myself, there's no way I'm going to get used to leveraging this sort of touchscreen experience for texting and typing emails and things like that. But very quickly, I was able to overcome that and fully leverage the real estate that this new smartphone has, the agility and the capabilities there, moving from simple calls and simple applications to a comprehensive and complete full application store, right? All that capability, things like storage, where we used to store information and contacts on the phone. Now it's all cloud-based and services-based, and enriching contacts and applications. You can kind of get the scenario here where the flip phone, where it was very good and very useful for a long period of time, it did have a transformation, and we needed that transformation to move into the next era of digital technology and communication. And we kind of relate that to the utility network and cloud services, but we're going to focus in on the UN specifically here because it definitely represents a complete technology paradigm shift here. This is not going to be your traditional data model migration process where we come from the geometric network, which again was very useful. It had a specific intent, and it fulfilled that intent for a number of years, probably almost 2 decades. But it was database driven, right? It was all about the database and opening up the capabilities and accessing different levels of there. You had some specific use cases with the geometric network around the connectivity and how to access that information. There was some challenges with having a sort of a distributed deployment, whether I was on the web or desktop or mobile. All those things sort of were independent of each other. But as we look at the utility network, we can see this paradigm shift where we're talking about a software product, a service-based architecture where we can access this information on any device anywhere. So we have a centralized deployment capability. The options for breaking out the information into sub-network support, but still explicitly being able to support the geometric and logical connectivity between the different utilities. So it's definitely a difference in thought that you got to have from moving from one to the other. And some folks don't even have a geometric to start off with. They just had points, lines, and polygons and created that relationship inside the GIS platform. But the utility network definitely introduces the next decade or two of how we're going to manage networks. So what are some of the things required to kind of get started here? Let's talk about sort of the 2 offerings that Esri has from the utility network perspective. The first one is the utility network foundation, right? This is that enterprise approach where you'll need ArcGIS Enterprise to deploy the UN in this fashion. It is all client managed environment. It's very customizable, allows you to open up and extend the capabilities of that. You can manage your versioning, your local schemas. We kind of see this as mid to large size utilities leveraging the enterprise approach, this utility network foundation. But Esri also has released and opened up sort of a simple hosted offering through ArcGIS Online. They call it the Water Distribution Data Management for ArcGIS Online. This is going to be for those smaller organizations. It's a very fast and lightweight for getting up and running, literally minutes to deploy. It's all deployed in ArcGIS Online. It's simple features. There are some limitations to network capabilities and versioning, but you still get to use things like ArcGIS Pro for that precision edits and topology management. And there is a file geodatabase option. So this is an area where we recommend to folks that are wanting to get started, who haven't, or maybe low comprehensive about or apprehensive about getting started. This is where you can see the schema. You can start working with the data model. You can understand the new naming conventions and how to leverage the different capabilities there without going full bore yet, right? So this is where you kind of do that jump start. And speaking of jump starts, we have jump starts for both of these deployment patterns and offerings. If you need help getting there, we can definitely get you started in the right direction. So let's continue that discussion and talk about what's required to get started from a platform perspective. I want to go a little bit deeper here because there are some nuances that you need to consider when migrating to the utility network, and then where to put those if you're going to leverage the cloud. So first off, ArcGIS Pro. This is one of those discussions where if you're not using Pro and you want to leverage utility network, you've got to get familiar with it. You've got to start that migration to leveraging ArcGIS Pro. Standard or advanced is available, and I know Pro is at 283, I think now, but minimum requirements is 2.4 with the UN add-in tools. ArcGIS Enterprise is available, is necessary. Again, we're talking about the enterprise approach here, both standard and advanced. ArcGIS Server must be federated with Portal because it handles user access through named user. So the UN licensing and extension is deployed. Now I'm throwing out some version numbers out there, and there's a reason behind this because technically you can go back maybe even further in the version numbers, but this is where we've seen folks really start to benefit the full with the full capabilities of the UN. That's that Pro 2.4 and or Enterprise 10.7.1 or higher. And at 10.8, Esri no longer required the UN extension to be deployed as well. They moved to a user type extension model, which is a really nice way to help control access and disseminate information. Now on the back end, you need to leverage the enterprise geodatabase. So Esri supports, the industry standards out there like SQL Server, Oracle, Postgres, SAP HANA. But I also wanted to kind of point out here that this has been around for a while. So if you're, again, apprehensive about even using this or a little concerned about leveraging new technology, this is not a yesterday type of deployment or release of the software. This has been in the works for years. And you can see from the versions of the software that it's gone through multiple iterations and enhancements and improvements. And so it's very stable. We've seen great success with helping our customers migrate to utility network and leveraging cloud services. So if you look at this infrastructure with Pro and Enterprise and database, how would this look like? What would this look like if we move this to the cloud? So I wanted to show you sort of an entry-level deployment option for deploying ArcGIS and the utility network in the cloud. So just focus on that top tier for a second. This is, what we consider the base deployment of ArcGIS Enterprise with those 4 components there, right? The portal, ArcGIS Server, the data store, the web adapters, and how we would typically start off a deployment in the cloud to maintain security through a virtual private cloud and public and private subnets and load balancing, and maybe managing port access so we could truly secure this environment. So this is your base deployment. So where does the UN fall in? So UN would be that additional server role. We would recommend implementing a additional server role to handle the utility network and its capabilities. And because of the license agreement that Esri provides for you, you can have an active production environment where the utility network would run inside of your base deployment of ArcGIS Enterprise, but you can also have what's called a passive production. So this could be on standby. This could be another component in your deployment strategy if you needed to have some level of high availability or redundancy built into your environment. You wouldn't have to leverage more licensing from Esri perspective. You can leverage the passive production offering that Esri provides, which makes it a really nice way to extend the deployment pattern within the cloud or on-premise for that matter. Now, one thing I want to point out here is ArcGIS Desktop. You see that as an option inside this cloud deployment. And this is one of those areas that we get lots of questions about, is where does desktop sit? And this is probably one of the areas that gets overlooked a lot of times when thinking about moving to the cloud, is where do my desktop users sit? How do they access the information and data? So a couple things here. First off, remember that the utility network is a new software product, and it's a services-oriented architecture, meaning that your ArcGIS Desktop could really sit anywhere because it's accessing the utility network over REST endpoints. It's a RESTful architecture that allows me to access that via a REST endpoint. So it gives us more options. But one option we can do is we can actually put desktop in the cloud. And we've seen different ways of deploying this, either through virtual machines or virtual workspaces. But cloud providers like Amazon Web Services are offering a streaming technology. Amazon's specific one is called app streaming. It gives us the ability to remotely access ArcGIS Pro, in this case, via a thin client, either a web browser or a thin client, an AppStream client, a client that you can download onto your desktop and then literally access ArcGIS Pro through that client. And Pro would be physically sitting in the cloud next to the data, next to the services, but you would leverage that through a remote thin client. And this is very unique because it gives us the ability to build out our environment for running Pro. And maybe I'm doing other things like 3D management or image processing or building out caching services. I can very quickly build out in the cloud a desktop environment to meet my specs for that particular workflow. And the cloud gives us that ability to only pay for what we use when we use it. So that's a great capability there. So pretty much provision and use on demand as I need that. So let's kind of switch gears a little bit, talk about the benefits you receive from both these technologies, the utility network and cloud services. So think of the UN again as that new software product, that services-oriented architecture. It gives us the ability to be connected and disconnected, but not lose connectivity between our networks. And these applications can be native, running on our smartphones and smart devices, web applications. It can be using information both indoors and outdoors, leveraging any device, anytime. So from desktop to tablet, all the geoprocessing tools are again seamless throughout the use of these because of that service-oriented architecture. So we get to leverage Pro, which is a 64-bit solution. We get to leverage Enterprise, ArcGIS Enterprise, which gives us that whole web GIS experience. We get that high fidelity data model, which explicitly brings out the connectivity, the terminaling, the containments, the associations, all those new capabilities within that data model. And sort of, to be honest with you, the way Esri has that architected out this environment, it's really hard to make bad data because of the way of the scheme and the model is built. It helps walk us through that process for things like 3D vertical assets, configuring different levels of access and tracing between the different networks. It's just again, I'll use that same term, the paradigm shift. It's a completely new offering and capability for managing networks now and into the future. If you compare that to what the cloud offers, I think it's best to kind of break this down into 4 categories. The first is sort of replacing that legacy environment, that on-premise environment, with new native technologies to the cloud, like load balancing, serverless computing, elastic storage and services, automatic updates, all of those offerings that are native now to these cloud providers, which gives us then the ability to increase our performance through optimized environments and infrastructures. Again, be able to scale up and scale down and have that elasticity within our environment, the reliability, the redundancy, all those buzzwords there are built into these cloud providers, and they have to provide those things, right? Because that's where they make their money and provide that extended capabilities. Cost, I think, is one that you really need to consider, because think about this: you're trading off capital expenses for variable expenses, things that you would have to have sort of this hardware refresh every 3 to 5 years. You can avoid that now and not have to worry about that because you pay for what you use when you use it. So sort of a pay-as-you-go model there. And in most cases, there's an economy of scale. So the more you use, the less you pay. And the longer you provision, the cheaper it is per month to provision those services. It's a really nice model. And I think finally, security and compliance. We can still maintain physical access through security. So we still control that. And in essence, there's this shared security model between us, the users of the cloud, and the cloud providers. So the cloud providers are responsible for security in the cloud, and then we help maintain that through security of the cloud. And it's a really nice fit and or compromise, which allows us to maintain some of the security aspects of the environment that we need to have. But to extend that conversation, these cloud providers are providing these sort of designated regions that are physically separated and architected out to meet U.S. Department of Defense security requirements. So things like FedRAMP and FISMA and HIPAA. These cloud providers offer these security offerings to allow us to sort of focus on our mission and minimize any kind of distractions of building out and managing in-house IT solutions. Let the cloud providers do that. We focus on the security model that's required for our environment there. A really nice offering if you need that level of security. Okay, so let's switch gears a little bit and talk about what you need to do to get started with the UN and or migrating to cloud services. And when we typically have this discussion, and again, I kind of remind you that we can do this independently and separate. We can have a utility network migration strategy discussion, or we can have the cloud migration strategy and instructions. But if you put these kind of two together, it makes a really nice fit that this process and this implementation, right? There isn't sort of a set in stone way of just doing this. And we found that over time working with our customers, we've kind of built out this sort of process and procedure where we start off with a readiness assessment and we move through these processes to get that modernized infrastructure management approach there. And I want to focus in on just a couple of these real quick. And the first one is the most important. That's the readiness assessment side of this. This is that set of processes to allow us to look and plan for what's really going to happen here, from those initial planning meetings all the way to this execution roadmap and documentation that supports that, to the reviewing of the infrastructure, looking at any staffing requirements that might need to be added or changed, or education or training. The data is always a big one. Again, it's a complete paradigm shift going from the geometric network or how you were managing networks prior to what's available to us now. The editing workflows, moving to ArcGIS Pro, desktop, understanding that level. And we always find that it's best to put together this working group to help develop this migration process and build in the confidence within your organization as we go through this whole procedure of moving either to the UN or to the cloud. Another process I want to highlight here is platform implementation. Now, this is all of them are important, but this one tends to require a little more focus on, because there's going to be this challenge of taking what you're using today to manage your utility network to how that's going to be in the future. And there's this process to kind of keeping things in sync. And we partner up with SSP to use their tool called SSP Sync that allows us to maintain two environments, so two network schemas, until we define that cutover date that we're moving from one to the other. So this really helps us leverage both environments until we're ready to do that cutoff date. We always like to deploy sort of a development environment to make sure that we're ready for that. The UN is very resource intensive, which is why I highlighted the additional server role capability for that when deploying within the ArcGIS Enterprise. We talked about the different versions that are supported and capable out there. We recommend at least 10.7.1 or higher, and you can see some of the other ones there as well. There's a whole new user type extension that's supported, which makes it nice for controlling that access. And I have a note here about Collector. Doesn't support branch versioning. If you're not familiar with branch versioning, that's the service-oriented architecture way of managing the utility network. Now, a note here, Collector is being rolled into the new ArcGIS field maps, and field maps has the ability to support branch versioning. So as is making a nice adjustment and supporting field data collection as they move forward with that. So again, I think the timing is perfect. Field Maps has been out for about a year now. The capabilities of Collector and ArcGIS Viewer and Navigator and things like that are making their way into Field Apps. So it's a really nice a time to leverage those technologies there. And then finally, I think as equally important is education and outreach. This is one of those things that although it's identified here as a specific process, this is something that takes place throughout the evolution, throughout the change, because we know change is scary, especially when moving to big technology shifts like the utility network and or cloud. So again, that working group is vastly important to maintain and advocate that change and to help people understand that, how it's going to be, how they're going to be impacted, and the things that they need to learn about that, and offer training. Be flexible and make sure that folks understand that this is going to be a process. There's going to be some training and some activities associated with that. So what I have to do is kind of finalize this presentation with some of the things that you can ask yourself, right? First off, do I have ArcGIS Enterprise? Utility network is a service-oriented based architecture, which means it leverages that environment. I did offer and open up the idea of an ArcGIS Online or a file geodatabase approach to getting started, which is a great way to familiarize yourself with that new schema, the new services, the way of accessing them through ArcGIS Online. So that's one way to get started. Do you have a standardized data model? This really affects the migration strategies to the number of customers, the connections, the system size, the types of systems. You have water, sewer, storm, others. Those will definitely impact your strategy for migrating. Are you using ArcGIS Pro? Do you have access to that? Are folks in your organization getting familiar with that? Remember, Pro is where you'll need to be, especially for migrating to utility network or other service-oriented architecture schemas, like the parcel fabric is another one that has re-released. Pro is going to be the way to go to do that. And we all know that ArcMap has, as we have stopped enhancing and improving ArcMap, they're still supporting security patches and things like that, but there's no more improvements in ArcMap, so it's time to make that switch. Do you have third-party tools or business systems that might be affected by migrating to the UN or any existing non-UN network that you have in place? So asset management systems or billing systems, SCADA, things like that, that might, again, be impacted or affected by this migration, especially if you're moving to the cloud. How will on-premise business systems be affected if I move the GIS up to the cloud? Again, desktop falls into there. And do you need help, right? We're here to help. We've been doing this for a number of years. We started off when the UN was in its infancy, and in the early stages there, we have a team that's just dedicated for this process, helping folks understand what it takes, what it truly takes to move from the old tech to the new tech, especially from the cloud. We've been doing the cloud for a long time. So in review, we talked about the platform requirements and licensing and how to access the environment, the different configuration options for getting started with the UN and cloud. We talked about the benefits from both the UN and the cloud, what they both provide, and bringing these two technologies together really, I think, modernizes the architecture and the infrastructure for managing both, or for any network or utility or other data management processes. And we looked at some things that you need to do to get started, some questions you need to ask yourself, the processes that we put in place here. Again, these are ones that we've kind of honed in on and fine-tuned over the years, helping our customers move from one to the other. So I thank you so much for taking time to listen. Again, there's that QR code if you want to scan that and get my contact information. My email's up there, or you just go to gisinc.com and ask for assistance to get started. We'd love to kind of talk to you about this and see where you're at in your migration to either the UN and or cloud services. So thank you.
Thank you, Steve. Does anyone have any questions for Alex or Steve? You can also feel free to put them in the chat if you don't want to speak out loud. If no one has any questions, not sure if Alex or Steve, if you want to do anything else, and we still have 20 minutes left that we can use. If you'd like to do another presentation or anything, otherwise, I believe that would conclude our session here.
Thanks, Anika. I think we're good. I think I'll just yeah, if there's anybody that has any questions, just reach out.
Yep, same for me. I think I went over everything I wanted to, so thanks again.
All right, that sounds great. Thank you guys so much.
Thank you. Bye-bye.
Yep, thanks again. Bye.